And then we watch.
If like you were gone or something when I passed it back, I usually put it over there. You probably don't have too many in here, but you can use them in mine.
Good thing is it's mostly small.
I think that's pretty fair also. I was just gonna take my interviews.
Hey Sylvia, what? It's my mom. It's my mom. You did not hate. Next week?
I'll like this, like actually do that. I've already done that.
I had the most bizarre and yet show-upon experience.
Yeah, we're putting on AP exam, the second AP exam, because our spring training was terribly planned. So every night from 6 to 8:30 during the during the AP exam, like we have to do march exam.
It's out of old, like you have to say.
I wasn't here last Thursday for our meet, and then I won't be here this Thursday for the after meet. So I missed the mini quiz on the first 3 or whatever it was. But tomorrow during advisory, I have to practice the presentation.
It was probably.
And then Thursday I'll be out for.
It only takes like 2 minutes.
Okay, I can probably come in before I have to go practice tomorrow. Okay.
As long as you do it before the AP exam.
Okay.
You can get exempt. I thought you could get exempted if you
I'm sorry, but like, my brain
I also have a wider, I just don't know the way to get it.
The thing that would help.
I don't think that was working. I need to try to fix it or trash it.
Talk about
They are obsessed with questions like that. The grade at meeting
it's not really that, it's just based on like how well you
Do we need to get it on? You got the big chair.
It would be so loud. I just noticed right now.
You don't need it today. I'll put it under bell when you need
That
it.
is what I call love.
Oh, that's what I thought.
Alright, if you did not turn in your homework, which was 122, the circuit over the basic integration, no use substitution stuff, then you need to make sure you got your name on it and come turn it into the basket before we get started here. Obviously, if you turn it in Google Classroom, you don't have to turn it into both. So. All right, our plan today, well, I'll see you guys 3 times this week. This is a B week, so today, Thursday, and Friday. Next week is not a B week, so I will only see you twice, but some of you may have an AP exam on Tuesday and or have an AP exam on Thursday. So, depending on that, will kind of dictate how many more classes we have together here. But I want to give you the same slideshow that we did last class, but I'm going to go through it a little bit quicker. I just want to hit on that a little bit each class to point out a few important motivational type things. And then one of the handouts you guys picked up is 128. It has 2 FRQs on it, but we're going to do one of them. The other one is just for your extra practice if you feel like you need it. But we'll talk about what that is and why we're doing that one. And then I've got a few handouts that are called topics that will be on the AP exam. So today we are looking at the first of those, which is number 129. So I'm going to quickly tell you some things that you can absolutely count on being on your AP exam. Go over an example of each as a quick little reteach, and then ask you to practice 1 or 2 more of each of those. And then if you finish that with some extra time, you can continue working on 127, but I've not given you any significant time to do 127, so I don't expect that to be finished yet. After, please. Okay, so first up, this the same slideshow that I shared with you last time. So, pass rates for Fayetteville High School. What was important about this? Why is this slide worth sharing?
Why are we sharing this? It gives you like an idea of like past success.
Correct. Gives you an idea of how many people are passing, but the main thing to me is it is not an automatic. If you don't study before the AP test and or you do not go in focused to do your best, then there's very likely that you could have passed, but a lot of people do drop the ball at the end. Okay, the second slide was pass rates for worldwide. What I wanted you to get out of this one was just to see that it's pretty consistent. The percentage of people that get a 3 does not change very much. So if on your AP exam you started and it seems like it's easy, you should not relax. It could mean that it's easy for everybody and the pass rate could be higher. Likewise, if it seems insanely hard, you should not give up because it's going to be hard for everybody and the pass rate might be lower. They're very consistent because that's why they do this sliding scale. This workshop from a couple years ago, I know it says last week, I just still forgot to change it, but the guy who did this workshop was one of the College Board people, so he's an AP grader, not just a regular AP grader, but like one of the leaders, so he has more insight to some of this stuff. And again, this is like 2 years old now, but I'm sure a lot of this is true every year. So one thing he said was that half of the people that got 2s would have had 3s that year, the year before this, if they had just gotten 3 more points overall. So if you end up with a 2 and you did the best you can, I'm happy with that. But if you end up with a 2 and you had some extra time and you didn't check your work and you forgot some things that you were supposed to memorize because you didn't look them over and you could have had a 3, then that's where I would be disappointed for you. That year, it only took 11 points to go from a 2 to a 4. So 11 points is, you know, a handful of questions, but that's also a big jump. Anything on a calculator FRQ, you need to write down what you're putting in the calculator. If you just go straight to the answer, that's not going to be worth anything. If you have any justifications or explanations more than a sentence, you're probably on the wrong track. And you don't have to simplify any arithmetic. According to him, and again, there's no guarantee with this stuff, and it's a couple years old, but he claimed that one FRQ is always the geometric area type That's the type that we have practiced a lot of, where you find like the area of a semicircle and the area of this triangle and the area of that triangle and add them up. He also claimed that one FRQ is always a rate in, rate out, which is actually the type of FRQ that we're going to practice in just a minute. So again, I don't know if that will still be true, but he seemed to think that that was going to be a constant. Always around the 3 decimal places, and if on an FRQ it says your function is differentiable, just go ahead and write down that it is also continuous, because sometimes there's a couple points that are kind of hidden behind that, and if you just write it down, if you don't need it, it doesn't hurt anything. It took you 5 seconds to do it, and if you needed it, sometimes there's a point or two that it's not possible to get without saying that. Any questions about any of that stuff? Okay, and then the part I had blank last time, and I wanted to just kind of move on. Some reasons to pass the AP exam. So I did go ahead and let my 4th period throw out some ideas, and all I want to see is if I share this with you each day up until the AP exam, if there's something I think that you are missing, then I will add it in at the end, but I'm a little bit more interested in what y'all think. So this is what 4th period added. So is there 1 or 2 more things, motivations that you have?
Say kind of imply the first one.
That's fine. I mean, I would think that would be the main reason for most of y'all. What if you don't think you need calculus? Is it?
Always a good thing to have, you know.
Is it?
It'll look
Differentiate
great on
apples
your
at a store or something.
Exactly.
So there's no use for calculus for passing the AP test? Okay, so one thing y'all need to understand is college, just like high school, expects you to have a number of electives for whatever degree you get. They're going to expect you to take an extra, 15 classes over your 4 years. So if you decide a major that does not need Cal 1 to get that diploma, that degree, they're still going to let you count it as an elective. So that's still 3 or 4 more hours less in college you would have to take, 1 less class you'd have to take, that many more homework. You won't have to pay for those hours. So even if you don't think you need calculus, at this point you guys have done the work, so I wouldn't quit now. What?
I would say if you failed it, you know what you might need to work on for when you go to college.
Okay. What would I type down for that though? Because that's more of a reason to not, or it would be like, I don't know how to word that.
Just say college would be easier.
Yeah.
Okay, college would be easier, that's for sure. I don't want to go on too many rants today, but do y'all realize that it is very difficult to get a degree in 4 years? Have I ever talked about that?
Especially.
Okay. It's old, but there is on that bulletin board over there part of a newspaper article that came out, I don't know, in 2008 or something. Like I said, it's pretty old. But they did some data on students who went to schools in Arkansas. How many of them had a degree after 6 years? Not after 4 years, after 6 years. The thing about a university is, if you want to take 2 classes one semester, they're going to let you take 2 classes. If you, that doesn't mean you get to finish in 4 years if you're taking 2 classes a semester, though. So, obviously, the less classes or the more credits you have going into college, then the less you would need, which makes it much easier to do in 4 years. Okay? Yeah.
Oh, I know, yeah. I forgot what it's called when you get a certain amount. I don't know if it's if you pass it or you get a certain amount of 5s. Don't you get recognition from college board, AP scholar distinction or something like that?
I don't know. I'm not sure about that. Yeah.
Bragging rights.
Okay. To who?
In parentheses, say specifically to research or something like that.
Well, that could be. Oh, I thought of a good one. I gotta write it down. I'm not sharing it today, though.
Could it?
Nope.
You can't do that.
No.
Every social contract.
No.
It's violates the social.
Do we have one?
Trying to teach us patience.
I'll write it down for later. What? No.
What could it be?
No.
The exam is just like.
I guess.
When I tell you, you'll see why I waited to tell you.
Are you gonna wait till afterwards?
No.
Are you never gonna tell? Is he like into the class that way?
Do we get another day?
Yeah, when are we gonna know?
Is there like a riddle?
I don't know.
Is it gonna be a meme?
No.
Oh yeah,
Okay.
do that. Put it in your email.
Please.
That was.
I don't know if it would fit. I'll see if I can find one. Okay, let's move on. All right, first off, so this page that has 2 FRQs, again, I'm asking you to do one of them. The other one is just there. I felt like it wasn't taking an extra piece of paper, so I was just printing you the back one, but that is completely optional. The front one, I'm actually going to give you 15 minutes and ask you to put in a full effort into one of these rate in, rate out type of problems. This is one that you certainly need a calculator for. So if you don't have a calculator, you need to get that sorted. And like we've done in the past, I'll share the scoring. We can talk about any of the math that we need to talk about. And on this one specifically, there's a calculator trick that I think would make this easier that I doubt any of you know. There was one person last period who actually knew how to do that calculator trick. But I'm not going to tell you beforehand because it's not necessary. I just think you'll appreciate it once you see what this is like. Okay, so the front one is the one I want you to do. The one that says 2002 FRQ2. So I have been trying to look up the averages on these. Go ahead and start, please. I have been trying to look up the averages of these, but College Board has this one linked to 2003, so I think they don't know that it's incorrectly linked. So I was not able to find the average on this one. Okay, the timer has started, so please. And this one is also a little wordy, so. Just do what you would do for the real test. 15 minutes is up. So let's check out the scoring. Again, I feel like this one is a little bit harder to do in 15 minutes. It's a little bit wordy at first, and I feel like it's pretty heavy on calculator, like how much stuff you're having to type into the calculator is slowing you down quite a bit. Okay, but as always, let's go ahead and worry about the grading piece first, see how it was graded, and then we can backtrack and talk math questions as needed. So part A was worth 3 points. So they give 1 point if you got the limits correct. So 9 to 17. Why is it 9 though and not 0? Isn't it normally 0 at this?
Because the function style is from 9 through 23.
Right. So if you didn't read the question before you started, you probably either missed that or you had to do more work and backtrack. So 1 point if you just got the 9 to 17. You get a second point if you got the thing you're taking the integral of, which would be e of t dt. Now you can either write out what e of t was equal to, or you can just put e of t. I will caution you that if you write out what e of t is equal to, but you like miss a 0 or miss a squared or something, then you would lose that point. So it's a lot quicker and safer to just say e of t like that. So that was point 2, and then point 3 was the answer. 6,004 people. I feel like 3 points for that one part is pretty generous. So, anything immediate about that? Okay. Again, I give you a chance when we look at the rest of them. Okay, part B. I felt when I did it this morning as well, I felt like I spent a little bit of time on part B, to be honest, and surprisingly they only gave 1 point for the setup on this. So my guess would be is that they started grading these and realized that there was almost nobody was getting the right final answer, so they probably adjusted the scoring a bit and made it where you just got a point if you set it up correctly. So I set mine up like this, which basically amounts to $15 times the number of people that enter from 9 to 17, plus $11 times however many people enter from 17 to 23. But you could have also done this, since you knew from part A how many people entered from 9 to 17 already. This is your answer from part A. You could have multiplied it by 15 plus $11 times the people that entered from 17 to 23. But you did not even have to come up with the answer of $104,048 or $41. Just a 1 point if you got it set up correctly. Okay, scoring questions there. All right, part C. Got a little bit more going on here. So it asked for the value of h prime of 17, and that was negative 380.281. So I wrote out what h was equal to, and I took the derivative, which ended up being fundamental theorem of calculus, and this is where that came from, and then plugging in 17, and then my calculator gave me that answer. Then it asks you to interpret what h of 17 means, and that was how many people were in the park at t equals 17. And then 1 point if you describe the meaning of h prime of 17, which would be the number or the rate that people entered the park. So you could either say the rate was negative 380 people per hour, or you could say it's decreasing at positive 380 people per hour. Yes.
How did we get the negative 380 again?
From this?
Yes. We like, is it just like you plug in 17 to both of those and you get that?
Yes.
Okay.
but do you know why this is equal to this? Because that's probably more important.
Right, yeah, because it outlines in the beginning.
Okay.
Yeah.
All right, and if instead of saying at t equals 17, you said 5 p.m., that's fine too. Those are equivalent in this question. But sometimes they do take away a point if you don't refer to something that's very basic. So if you got the right answers to those, but you didn't refer to t equals 17 in any of your work, or 5 p.m., which is the same thing, then they take away a point.
Do I need the units? Like I just say, like I said, h prime of 17 is the number of people leaving the park. Do I need this to people per hour, or can I just say that?
Honestly, I'm not sure. To be safe, I would say try to put the units, but I don't know if they really scored it that way or not. I think I mentioned before that like they give this as like a quick scoring guide, but like the real one is usually like several pages for instances like that, and they don't share that with us. So okay, so you could get up to 3 points for part C, and then finally 2 parts for part D. So you wanted to know when, not what the maximum number of people in the park was, but when, at what time was there the maximum number of people. So I did like a candidates test, which wasn't needed this time, but a lot of the times it is. I checked the endpoints, which was 9 and 23. And I checked for critical numbers, and critical numbers come when your derivative is equal to 0. So I graphed these two. If you want to know when this minus this equals 0, that's the same thing as wanting to know add this over when they're equal. So I graphed them and looked for a point of intersection. That was the critical number, and it ended up having the biggest number of people. So you really needed to find that from the graph. Yeah.
If you just put into your calculator graphing E of t minus L of t, could that work as well? Like, is that how you put it into your graphing calculator?
What I did on the graphing of the calculator, blue is E of t, and L is red. So since I added the other one over,
Just wherever they
wherever they intersect. So you could also do equation solver. The problem with equation solver is it's only going to give you one answer up front, and you may have more than one answer. So a graph, you can kind of see it real quick.
Do I need to mention E of t minus L of t, or can I just mention h prime of t?
I think that would be okay. I think that would be fine since they're equivalent. Okay, so total up how many points you got there. And again, there's still one more thing I kind of want to mention about this one that I think makes this one hard to do, especially in 15 minutes. So very likely, and again, this is completely optional, and maybe it's not going to help you on your AP test, but I hope that it helps you at some point. This is a big function for E of t, and there's a pretty big function for L of t. But even just looking at E of t, do you see how you had to type it in your calculator once for part A, once or twice for part B, once for part C, and then once for part D. So that one big function, did you feel like you were entering it in your calculator multiple times?
Yeah.
Yes.
And it's you know, it's a big fraction, so if you're not careful and you hit a wrong button, then it's all for nothing, and you have to slow down and be careful. Well, there is kind of a thing that you can do to make this a little bit better. So if you type in one of the functions for like y1 and a different function in for y2, this is how I did it earlier today, and I just carefully entered them in, and I double checked them because this is the only time I typed them in my calculator, just one time. So then for part A, I realized that the answer was going to come from integrating from 9 to 17 E of t. But do you remember how I put E of t in for y1?
Yeah.
Well, this button right here stands for variables. If you click that, go to the second tab, option number 1, it lets you select these things that you type in for the graphing. So since I typed that in for y1, I don't have to type in that mess a second time, or a third time, or a fourth time. Does that make sense? And then instead of L of t, I just did y2. But you have to know that you can do that, and you have to know where to find those. So they're probably in the catalog, since everything's in the catalog. But variables, second tab, option 1, and then you can pick. So this would be what L2 was for me.
Is it possible to also just store it in something?
I mean, this is the only way to store a function. You can store numbers with the store button. You can like store a number in for x, but you can't store a whole equation in unless you do it like that. So and I did that partly because I think I did this one a couple years ago, and I was annoyed that I was typing in the same thing over and over and over. But if you realize that you're going to do that, again, just consider typing them in once, check them carefully that one time, and then just know how to pull from them in the calculator. So, just a suggestion. All right, the next piece we're looking at today is the other two handouts we've got. I've mentioned that as far as review time goes, we are, bare bones here. So there are some topics that sometimes get asked, like every 5 years they might throw a certain type of question on there. Every 3 years they might throw a certain type of question on there. But some topics will be on there every single year. So if you guys are aware of what those are, make sure that you are well prepared for those, knowing that you're going in ready to get those 5, 10, 15 points. Then of course that's going to make you feel a lot less stressed on that actual test, knowing that you've got a little bit of a safety net. So what we are going to do with this first one is we're going to review a couple of these topics. So I'm going to do one question of each of these again as a quick little reteach and give you guys a chance to speak up and interrupt if there's something you don't remember. And then I've got 1 or 2 of each of these that I want you to go back and do. So we're going to review solving differential equations, often multiple choice, and when it's part of an FRQ, it's usually 5 or 6 of the FRQ points. So very important. The definition of a derivative and the alternate form of a derivative will be on your AP test. Probably just one multiple choice, but still, the more familiar you are with it, the more likely you're going to get that. The derivative of trig functions and integrating trig functions, making sure you have those memorized. Riemann sums and trapezoidal sums. And then on the last page, implicit differentiation. Now, these are not the only topics I can promise you that will be on your AP test, but these are the ones I want us to focus on today. So, back to the first one, solving differential equations. I didn't document this very well, but all of these are released questions. So I don't know what year it was, but some year, question number 37, this was the exact question that they had. So they give us a derivative, and we're supposed to come up with the function. So what was the first step that we usually did in doing that kind of stuff? Okay, separate the variables. I heard that. Get all the y stuff on one side, all the x stuff on another side. Now, for these, again, I'm going to do one of each of these with you. So the first one, all you need to do is at least copy down what I'm copying down. You're welcome to add to it, but at least get down what I get down. Okay, and then why did we do that? Okay, so the integration works out nicely. Multiple choice, you don't usually, this is multiple choice, but a lot of multiple choice, you're not going to forget this because it's going to be in every single answer. But don't forget that you need a C. There could be a constant in there. Sometimes they're going to give you information to solve for C. So when y is 4, x is 0, So then you can plug it back in. And we're trying to figure out what y is equal to. So now we had to do some algebraic manipulation stuff, which can be very easy. It could be already done, and it could take a couple more steps. It just depends. So in this one, how did I dig this y out of the natural log? Good. Exponentiate. So e to the log base e of absolute value of y is going to be absolute value of y. We probably don't need the absolute value signs, but we'll keep them for just a second. Over here, we often split this up. This is like e to the 4x times e to the natural log of 4. When you multiply things with the same base, you add the exponents. You're just used to going the opposite direction. But we need to do that in this question because what is this equal to? Right, the same way that this equals the absolute value of y, all of this equals 4. And now in the end, to know, because remember absolute value, it could equal this stuff or it could equal the opposite of this stuff. It could be the negative version. Now, you got a little bit of a hint here. How should you know what the answer is? Right, there isn't one that's a -4, right? So you could just do that and move on. But the way that you have to do it, if that had been a choice, is you have to plug this back in and make sure that it works. If I plug in 0 for x, it's supposed to give me +4 for y. And if it was supposed to be -4, I would know to make this negative. That's the only way to get rid of that. So they're not going to give you a ton of multiple choice questions like this because these are a little bit more time consuming. But I'm sure there'll be at least one, and over the last few years they've been very popular for FRQs, so 5 to 6 points if that happens. Anything you want to ask about that, or anybody need this one up on the board longer?
Could you go over, sorry.
Go ahead.
So we just have a C because it's defined, and because it's defined, then you plug it back in. Could you go over like the plugging in part again?
Sure. So this underlined in gray here, because they're giving me this initial condition, I could take what I got after integrating both sides. I just plugged in 4 for y and 0 for x, and that let me know what C was, and then I just went back and plugged it into the step before.
Okay, got it.
If there's more information, we can figure out exactly how big C is.
Could you go over the absolute value?
Sure. So absolute value, so just to look at a basic one, there's two answers to this. Either this could be a +2, it could just equal the other side, or it could be equal, x could be a -2. And it's kind of hard to see because when you take the absolute value of it, it turns around. So the stuff under an absolute value could be equal to the other side, or it could be equal to the opposite of the other side. For us, when we do that, you really shouldn't drop these absolute value signs. Don't make them just go away until you consider that. Since we know it goes through 0, 4, when I plug in 0 for x, I get 4 for y, and that's how I know that it was the positive version. But if this initial condition had been 0, -4, and I saw plugging in 0 for x was giving me +4, I know it would have been the negative version, and I would need to slap a negative on there. But that's what you have to do to fully make sure that you're careful with that. Okay, those are good questions. Anything else on that? Okay, so in a few minutes, after we do one of each of these, here's one more I'd like you to go back and do. So from 2016 FRQ4 Part C. Here's one more I want you to practice. Now, I'm not going to dwell on this on a lot of these questions, but if you realize solving differential equations is a skill that you're struggling with and you want some extra practice, I did directly link some Khan Academy stuff to that. Of course, Khan Academy is good just for the drill and kill practice. But okay, second skill I want you to review is the definition of a derivative and the alternate form of the definition of a derivative. So there's really no way around. You have to memorize these two. And they're not going to ask you a million of these questions, but it will be on there because conceptually this is very important. This is why we have to start with limits instead of derivatives, because a derivative doesn't exist without a limit. And now I've been putting this one on the when you see this is what you do quizzes and study. And of course I hope that that's going to make this a little bit easier. But when I look at question number 6 down here, and I look at what they gave me, this setup, this is the definition of a derivative. So they're asking me to do some kind of derivative, but I've got to interpret what this mess of stuff is trying to tell me. So if you realize, well, which one of these two does it look more like? Right, based on the denominator, at least I would say it looks more like the top. So f of x is supposed to be this stuff right here. So when I look at that, it looks like f of x must be 8x to the 8th, and they are plugging in 1/2. So once I recognize what the function is, I can find his derivative. I can see that they're trying to evaluate it at 1/2. So if I plug 1/2 in here, 1/2 to the 7th, well, let's just do 2 to the 7th and we'll do the reciprocal. So that would be 2, 4, 8, 16, 32, 64, 128. Except it was 1/2, not 2. So it would be 1 over 128, and that simplifies to be b. It's not that the derivative was hard. The evaluating also wasn't terrible. This would have been a non-calculator question. But if you can't look at that and say, okay, they're wanting me to take a derivative, the function is 8x to the 8th, and they're wanting me to evaluate it at 1/2, then you just can't do this question type. So, specific questions on that before we go to the next skill. These type, I would also say that they get a lot easier if you practice a bunch of them in a row. Sorry. Okay, so I've got 2 more of those for you to try, and a bit.ly link if you know that you need to practice more of that. On to the next page. You definitely need to know the derivative of your trig functions. Hello? Okay, I'll let her know. Karina, you're checked out. Okay, so this works for derivatives, since it's just the opposite direction. Again, I hope that you guys know sine and cosine. And also comes up fairly often, but these other 3 are also, they're not going to dominate your AP test, but I would hate for you to miss a few questions just because you didn't know those. But for question 4, the derivative of x would be 1, and the derivative of sine x would be cosine x. And that was all that was for that. As long as you know your trig derivatives, it could have been any other one in there and it wouldn't have been any more difficult. So. That one almost seems too easy. Like something's wrong with it.
Wait, what would be the next one? Like,
That's
to 8th grade.
That's the one I want you to try. I'm going to give you time in a few minutes after we do the rest of these. Also, I meant to give you the answers to the ones I want you to do, so I'll do that after we look at each of these. I want you to know that you got it right before you move on. Alright, next to last one would be Riemann sums / trapezoidal sums. So, of course, you need to know the area of a rectangle formula, base times height, length times width, whatever you want to call it. I'm less concerned about that one, more concerned about the area of a trapezoid. The height times the bases added together, all divided by 2. Now this is kind of a very specific example, but the year that you guys got out of school early because of COVID and everything was virtual, that year the AP test was 2 massive FRQs, like 10, 15, 20 part FRQs. But what was unique about that year is they would send me the work of my students so I could actually see what they put on their paper. And there was one student, I won't say their name, but one student who was very, very, very close to passing that I could tell based on the work that I saw. But on his test, they had him do a trapezoidal sum, and he didn't use the area of a trapezoid correctly sometimes. Sometimes he did. There was like 3 of them or something. He did it right once or twice, and then one time he did like a minus sign instead. And honestly, it might have been the difference for him to get it from a 2 to a 3. Like his was very close. So I would just hate for that to happen to you. Okay, so an example of how to use this, number 91, we got a left Riemann sum, 3 subintervals, equal length. So I actually do the same thing on my paper, not with different colors, but I try to highlight these. Like there's going to be my first rectangle, second rectangle, and third rectangle. I like to be able to see them a little bit. Now, of course, you could also just make a graph and plot those 4 points and then have a visual that way too, if that's better for you. But I'm adding up 3 rectangles because this is a left-hand Riemann sum. Looks like the width of this guy is 2, the width of this guy is 2, and the width of this guy is 2, which makes sense. They said equal subdivisions. They're not always equal in these charts. Now, because this says the left-hand Riemann sums, what is the length of my first rectangle?
5.
Good. It's going to be the y value along the left side. What is the length of my second rectangle?
2.
It's the y value on the left side. That makes it the left-hand Riemann sum. And then the last one, 8. So the answer came from 10 plus 4 plus 16, which was 30. Arithmetic's not going to get any easier than that, but you got to make sure that you can sort through the information in the table. Okay. Anything you want to ask about that one? These are often FRQs as well.
The question itself, I mean, is that information about like the velocity at t equals 0 is 11 feet per second? Is that just like nonsense?
Velocity is 0. At 0 is 11 feet per second. I mean, a lot of this stuff is just already in the table. They're saying from like 0 to 6, 0 to 6. This would be like your starting velocity. It just wasn't needed for the rest of that though.
Okay.
Yeah, some distractors. Okay, so the next one that I do want you to do is a trapezoidal sum, and then interpreting what a trapezoidal sum may represent. And we just saw that on our FRQ today, that they ask questions like that. But let's go down to the last one. The last skill I want you to practice today and between now and Thursday is implicit differentiation. So I've got a multiple choice here and then an FRQ part that I would like you to do. So the main thing about implicit differentiation is you have to make sure that you're paying attention to what you're taking the derivative with respect to, usually with respect to x. So when I take the derivative of x squared, I'm just using the power rule, getting 2x. Technically, I just took the derivative of x with respect to x, but this is like multiplying by 1, and it doesn't do anything, so we don't really need to keep up with it. But the next part, well, this is x times y, so unfortunately we would have to do product rule. The derivative of x with y left alone, and then the derivative of y with x left alone. And because I'm taking the derivative of y with respect to some other variable, I have to have a y prime. Okay, and then what about y cubed? What's the derivative of that?
3y squared.
Good, and then the y prime, that's the most important part. I mean, I guess if that's wrong too, then you'd be in trouble, but I once again took the derivative of y with respect to some other variable. That's the hardest part of implicit. Now, if I'm trying to solve this for the derivative, I'm going to subtract over anything that does not have a y prime. So like subtract over a 2x and subtract over a y. Then this step always happened with these questions. I've got a y prime here and a y prime there. So I could factor that out so that I can undo times with divide. The rest is algebra, and it's algebra that all of these questions basically finish the same way. So we end up with an answer of A. But the highlighted part's the most important part. That works the same way with related rates. You're taking the derivative of some variable with respect to some other variable like time or x, and it's not an x, you have to do the y prime, a prime, b prime, whatever the variable is. Okay, again, I know you've seen that before, but I'm also going pretty quick here. Anything that jumps out at you about implicit that you would want clarification on right away? Okay, I meant to do this at the start here. So the questions I want you to go back and do, I'm going to share the answers with you because I want you to know that you're doing it correctly. Of course, you need to show the work that leads you to that answer. But on number 2 on the front page, make sure that you end up with, just jot this out to the side. Make sure that you end up with an answer that looks like that. So there's only one more of those to practice today. Yes, Dave.
Wait.
Down here, these two multiple choice. This one is supposed to be B and this one's supposed to be E. So again, I obviously want you to work it out and practice it, but I want you to know if you're on the right track or not. So jot the right answer out to the side. Oh, and then D. B, E, D. On the back page, that example was really easy. This one we have to do integration, so it's a little bit harder, but it should be D. And the only other one to practice on this page is on the bottom of the page. It's multiple choice and should be C. And then on the last page, this one's a little bit wordy, but that's okay. Interpreting what this means in context of the question. The 1/10 was my hint that it was average, and this question was about temperature of tea. From 0 minutes to 10 minutes. Okay, and then there's one implicit that I'd like you to do at the bottom, but I don't need to tell you what the answer is because they gave you the answer, and this is what they usually do when it shows up on FRQs. They'll say this is his derivative. You just need to show that that's his derivative. So just like we practiced it earlier this year. So you don't have to go back and do the first topic first, but I do want you to go back and practice the rest of those questions. So go ahead and start on those. See which ones you get the same answers as me. If you're getting something different, work with your neighbor, call me over for help. If you don't get all the help you need in class, then come in during advisory, please. And then part of your homework will be to look this over for a mini quiz. So next class I will put together a 1 or 2, no more than 2 question quiz questions from these skills. So if you have forgotten how to do any of these, now is the time to get caught back up, because we need to look at other stuff, our other classes. So. And if you finish early enough, you're welcome to start on the U substitution circuit. But if you don't get to it again today, that's okay too. It's not due next time. What is due next time is these few questions that I skipped that I want you to practice and study it. Well, you should do natural log there. You should rewrite it with exclamation.
Oh, okay, got it.
We only do natural log if it's a variable to the first power. Check it. I mean, I might have had a mistake. I rewrote this as sine over cosine and did U substitution. I guess I'll check my work, but I did not check it by trying it backwards. That's true.
Because what about is like this one was more secant effects, and then you do the chain of this one. And secant effects cancels out the times the mass.
I love science.
Yeah, you might be right. Let me double check that.